As I was just saying, today we're going to talk about another factoring pattern, something that's cubed plus something else that's cubed, or something that's cubed minus something else that's cubed. We know difference of squares. We know that if we have x squared minus y squared, who wants to tell me how that factors? Thank you, Ricky. X plus y and x minus y. And as long as these are even, there's a way of doing it with that pattern. If it is sum of squares, we're done, can't factor it. If it's cubes or anything with multiples of 3 for the exponents, we can factor it regardless of whether there's a plus or a minus sign. So in that sense, it's nicer than the squares, but it's not quite as short of a formula. Here are the formulas if it is a sum of cubes. And again, all exponents must be multiples of 3 for this pattern to work. Notice the factorings are exactly the same, except some of the plus and minus signs are changed around. We always have a short parentheses and a long parentheses. To get the short parentheses, you look at the first one and take its cubed root. And you look at the last one and you take its cubed root. So x cubed, cubed root of that is x, y cubed, cubed root of that is y. Yes, Evelyn? Sort of, yeah. Some of those were kind of backwards on some of the polynomial division ones. Then once you have that and you want to get the long parentheses, you take whatever is first in the short parentheses and square it. You take whatever is last and square that, and it goes at the end. You leave a space in the middle. To get the middle term, you simply take both of these and multiply them. You don't multiply by 2. It's not like what you do if it's x minus y times x minus y, where you get a minus 2xy in the middle. There's no 2 in there. It's just those two things multiplied by each other. And then we have a little saying to help us keep all the plus and minus signs straight. The little saying is SOAP, and that's only about the plus and minus signs. What that says is in these formulas, your first plus or minus sign is the same as in the original problem, and your next plus or minus sign is the opposite of that, and your last plus or minus sign is always positive, the A and the P of SOAP. So what that means is right here, when I had a plus, my short parentheses had the same, and then I had the opposite, a minus sign, and then I had always positive. When I did x cubed minus y cubed, my first plus or minus, so the one in the middle of the short parentheses, was the same as that, so it was still a minus sign. The next one was the opposite of that, so it was a plus, and the last one was always positive. Yes? That's just the way that it works out. If you tried to FOIL this, that's what it's got to be to get things to cancel out and get back to x cubed minus y cubed. So just try taking this and foiling and combining like terms. If the plus and minus signs don't line up this way, things won't cancel out to get you back to, in that case, x cubed minus y cubed. You'll have an extra term in there somewhere. So we're going to go through some examples on this together and some on the whiteboards. just because this is pretty short and easy. So we know we need to get a short parentheses and a long parentheses, one that has two things in it, one that has three things in it. I start, what's the cubed root of x cubed, everybody? Just an x. What's the cubed root of 8? So now I've got my short parentheses. Now I look at that to get my long parentheses. I take the x times itself, so x times x is x squared. I take the 2 times itself. Everybody, what's 2 times 2? And in the middle, I take the x times the 2, which is a 2x. And then I do soak. I started with a minus sign, so this is the same. And then the opposite, and then always positive. And I'm done. Yeah. And you don't have to do the check, but if I FOILed the x times everything, I'd have x cubed plus 2x squared plus 4x. And then the minus 2 times everything in the long parentheses, I'd have minus 2x squared, minus 4x, and minus 8. And everything would cancel. And I have something that's equivalent to x cubed minus 8. So let's do another one. Okay, is y cubed something cubed? Is 27 something cubed? Okay, so we're going to soap this one. Short parentheses, long parentheses. What's the cubed root of y cubed, everybody? And everybody this time, what's the cubed root of 27? Then I do the first thing, y times y is y squared. I end with this 3 times itself. What's 3 squared? And then whatever the things are that I have here, I multiply together. So y times 3, put that in the middle. Soap it. This was a plus, so I keep a plus. Opposite of that, always positive. And we're finished. Questions? Hendricks. If you were trying to do it with that, you're not going to have ones that do that you're expected to factor in this course. But the pattern would still apply. We are going to see ones that are messier like this. Is 64 something cubed? Who can tell me what's the cubed root of 64? Okay, a bunch of people are holding up 4 fingers. So it is 4. Are all of my exponents multiples of 3? So I can take a cubed root of the number that I have. I don't have something weird like we were just talking about, like a 16 in there. 64 has a nice cubed root, and all of the exponents are multiples of 3. So I need to take the cubed root of the first one, so 4. And then anytime I'm not sure, p to the 6th, the cubed root of that, what's 6 times a third? So I divide by 3 basically to say p squared. A, what's the 9 divided by 3? So everybody good with the first part of my short parentheses? Okay. X, what's 3 divided by 3? So I just have x to the 1. Y to the, what's 12 divided by 3? And then I need my long parentheses. Now I need to take the 4p squared a cubed times 4p squared a cubed to get the first part of my long parentheses. What will that give me? Who wants to raise your hand if you can tell me 4p squared a cubed times 4p squared a cubed? What will I get? Anna? A to the 6th. Okay, I'm going to end with x y to the 4th times x y to the 4th. Summer, what will that be? Question? Well, because if I'm taking p squared times p squared, that's p times p times p times p, p to the fourth. A cubed is a times a times a times a times a times a to the sixth. We add the exponents when we have a power times a power. When we have a power of a power, that's when we multiply the exponents. Finally, in the middle, I need to take my first one, which was 4p squared a cubed, times my last one, which was xy to the fourth. Nothing to combine there, but that goes in the middle. Fix my plus and minus signs, same. So I start with a minus, opposite, and always positive. And there is my answer. Any questions before you guys try a couple of these on the whiteboards?